Again, welcome to Better BIM with Knowledge Graphs Co-Designing Buildings Digital Futures workshop. I prepared this presentation to show slightly the workflow and the topic behind it, but please feel free to stop me, ask questions. It's better if it's interactive. Again, just to show again, we are 6 people in this team who prepared the workshop and are working on this topic since more than 10 months for now. And we are an interdisciplinary team. We have people from the industry, which is the engineers from BHoM. Then we have researchers from and professors from the computer science department. And me and my supervisor, we are part of the Faculty of Architecture, working at the Chair for Computing and Architecture here at ICD. In this workshop, we will demonstrate how we can model building information using semantic web standards. And before we start, I would just like to see again, even that we heard, I would like to see again the background, how many of you are familiar with computational design, data information modeling, and semantic web technologies. To do it, please go to menti.com right now from your phone, from your device, and use this code. Can you? Okay, perfect. I'm seeing some votes. The majority is computational design. Yeah, so more computational designers, more. We have 8 people who voted, but we are more than this. 11. Perfect. Great. Yeah, 1 just is good in data modeling. That's good. Perfect. Nice. Great, we have good distribution. And I guess some people still didn't vote. I wait for 2 more. Great, nice. This is a good result. It's good somehow that we have votes in every field, and there is something to be learned in semantic web technologies for sure. Wow, 1 more semantic web. Thank you. Great. Now I go back to the presentation and I will save this result. Now, I would like to start the presentation with a question: what is a column? And we know that the answer probably depends on whom we ask, because as we know, a structural engineer might represent a building or a column. It might represent it differently. For example, a structural engineer can represent a building as a whole of columns, beams, and slabs. And then it can be further simplified as linear elements during structural analysis. And then an architect could see the building as a aggregation of spaces instead. And then similarly, other disciplines, they have specific requirements for capturing, storing, and presenting their relevant information. Therefore, architecture, engineering, and construction projects need multidisciplinary solutions. And then based on the properties that you add, you can also explore the designs how you want. And this is all the way how we model information. But as we know, this quote from George Box emphasized that all models are wrong. A model is a representation of something, and they are always wrong, right? They are not the actual thing. We use models to represent knowledge and data that we need. They are probably all wrong, but useful for the task that we are doing. I got this image from a research from TU Munich. It was presented last year in the European Conference on Product and Process Modeling, where they tackle a similar modeling question. They had a distributed heterogeneous information models. And the question is, do we need one monolithic model or do we need multiple representations? Because they were working with railways, as we see. Do we need a 3D model? Do we need the logic behind it? What is the model of the system? And there is not only one model, but there are different models that are useful for different tasks. So the question how to represent knowledge and how to model information was always there. What words, and then there are so many things that we have to think about. What words being modeled, what is the level of detail, what is the data that we need? And this is not a topic of the 21st century. I need to admit so on. And this is a topic that dates back to ancient Greek and before the Common Era. The study of being, or the kinds of things that have existence, the ontology, dates back to ontologies of ancient Greek. And ontology actually means onto, being, logo, study. So there was this field that deals with set of concepts and categories in a domain that shows. Please mute yourself. Melika. Okay, I'm muted. And the study that is studying these relations is called an ontology. Here below, you can see an example of a child and a parent and their roles model. This is an example of ontology. We have two parts. We have a parent, a child, and then we have some nodes that show, for example, this small existence, this small study of being. And Plato, who also contributed to knowledge representation models. Does any one of you knows Plato's theory of knowledge? Well, if you do, that's perfect. If you don't, you can check it out. I guess it's worth to see it. He gave structure to the epistemological comparison between science and opinion and believed that there are always truths to be discovered. And the truth is possible, but he states 4 stages of knowledge development. It's imagining, believing, thinking. And these things are based on some other things like soul or body, the physical and the thought. And then we can reach the perfect intelligence, like we see. I can use a pointer. Then we can reach the perfect intelligence, which, anyways, who is interested can check it. It's a very interesting way how you can reach knowledge on some facts, and then these facts are filled up with some other beliefs and thinking. So it's basically a knowledge graph in a way. And this is again the conceptual ontology of things that exist. But the science of being, the ontology, has evolved more than just a cluster of diagrams like we see here. And it is used in many fields to model and represent knowledge, to represent concepts of the discipline or of a domain. If you Google what is an ontology, you can see still the original definition. That is nothing more than the branch of metaphysics dealing with the nature of being, and the sets of concepts and categories in a subject area or domain that shows their properties and relations between them. So it's just branch of objects and their relations. And so there is a way, then there is always also a way how we represent knowledge in architecture, right? We have, for example, this is a column in IFC, and this is again the ontology, the logic, the data and the properties behind one column, for example. There's always a way how we want to model our data. And again, but the data that we model, I will keep here, the data that we model and the information that we show, sometimes in architectural domain is highly restricted and it's affected from the tool that we use, because the tool already provides us a container of data, and then we just fill it with information. And then we use some ad hoc methods that we just create our data on our own tool, or depending on what we use. So right now, again, I would like you to go back to Menti and just, can you write down keywords of tools that you use to model data and to design in your computational design workflow or your modeling information? I put here some logos. I'm not going to say what they are. Who knows, but they are just a reference. You can write whatever you use to model, to design, and to model data. How do you present your information? And I will see it live again here. Okay, so we had some more votes here. And now I would like to see the tools that you use to model data. Speckle. Good. Nice, JSON. You can also write design softwares if you actually are, let's say you start from a design software. JSON, beautiful color, Revit, yep. IFC OpenShell, cool. Python, Blender, perfect. We have one more speckle. We have BHoM. We have BHoM. Did you write it, Alessio?
No.
Cool. Blender BIM. I guess nice. Blender, Python, speckle. Perfect. Nice. Quite heterogeneous, right? Nice. And Excel, huh? That's good. I'm wondering how you can model, but you can model actually in Excel a lot of things. IFC, of course, is the standard. And Photoshop, that's brave, but it represents something. Mm-hmm. Yep. SQL, Dynamo, Power BI, and Pandas. BHoM is getting slightly larger. I mean, the size, probably, you know, the size, it's larger, increases when there are more than one people who typed it. So we have Grasshopper. Right. Grasshopper is the main right now. Python, Rhino, JSON, Revit. Okay, we have 18 people who voted. I will wait for 2 more. But the audience loves Grasshopper, and that's good.
I have a question. Are you familiar with Speckle? Because when I study in Bartlett, one of my teacher is the developer of Speckle, so we
Dimitri?
Dimitri or Matteo?
Paul.
Paul Ponnet.
Yeah,
okay.
Yeah.
Yes.
I don't think he's working with them anymore, but yeah, he used to work with them.
Yeah.
I did work with Paul. Actually, Paul was on internet, like working with us, co-located in Burhappold, and we did lots of work together. Yep.
Ah, great.
Yeah.
So
nice.
Now I still have some connection with him.
Mm-hmm. And are you the one who wrote Speckle? One of the ones, because many people wrote.
Yeah, Cyril.
Sidong.
No, I didn't write it. At that time, I just use it in our design project.
Yeah.
Mm-hmm.
Okay, I guess we can move on. We can see that Grasshopper is the main working environment, but to model data in Grasshopper, you probably need some plugins or some data structure, because it doesn't really have this layer of building information, right? It's let's say discipline agnostic, but you can do whatever you want, and that's good because it's quite flexible. I use, for example, before Elephant within Grasshopper to model my data, but now I use BHoM. Okay, now we continue. I save the results of this as well. And
sorry, a quick question.
Yeah.
You
Yes.
have an icon. You have an icon of ifc.js. I think the first one.
Did you write ifc.js? Yeah,
no.
ifc.js is actually, yeah.
On the previous slide, you have the icon for it. I wanted to know, like, what I know is that it's just like a way to represent it on the web.
Yeah.
But is it like, can you tell or maybe speak a little more about like what exactly?
Well, right. I've talked with a guy who actually was working on this. I saw one of his presentations and I see that it is more than just a viewer. You can have also some functions, but the beauty of it is that you are not tied to a commercial software, but you can directly use it on the web. And that is a good way because data is migrating on the web. You can, at the moment, you could not create one IFC file from scratch, but you could open it and work with it on the web. And then there are also some functions that you can apply. Okay. And actually, it's developed quite well also with a knowledge graph and link building data community, because already you can query some information, you can parse it based on some ontologies that we will see right now. I continue on my slides, but yeah, I think IFC.js. I think IFC.js is a future also design tool. Okay, now we saw also from the chart and in a typical code design that we can have different design tools. We saw Rhino, Revit, Grasshopper. We saw Excel, Dynamo, and GraphDB as well. Follogram, I see there, GeoJSON. So we have different design data format, and we have different tools. And usually this format is dependent from the tool. And in a typical code design, all this data needs to be linked, needs to be exchanged. And not everyone uses the same tool. We need to drag something from Rhino to Revit, from Sophistic to Archicad, and there are so many ways to do it, and there is no standardized way to do it. But as we know, some data might be relevant maybe just for the latest design, construction and fabrication design in a linear design process, and some of them might need just in the early stages of design. But as we know, the most critical design decisions, they happen in the early stages of design, and they don't influence just construction costs, but the subsequent building energy use. So we need to consider data from every stage, every discipline of design, and integrate this with each other and communicate restrictions from each other. And this is what an integrative approach that considers, therefore, an integrative approach that considers design and analysis methods, manufacturing and construction processes, as well as material and building systems, such as co-design, must integrate data from multiple disciplines starting from the early stages of design. And this is what the Cluster of Excellence, Integrative Computational Design and Construction for Architecture here at the University of Stuttgart is aiming for. They are trying to rethink design and construction in a comprehensive manner to harness the full potential of digital technologies and to think design and fabrication and construction data in an interdisciplinary manner. So now, how do we interoperate, and what kind of data schemas or platforms exist for interoperating? We saw before, Zidong mentioned Speckle, and here I presented 3 of them. Let's say the key ones that are used for interoperability. We have the good old IFC. It's a standardized data schema based on the Express data model. IFC represents data in a monolithic approach, meaning that we have one data container for, as we saw the column, everything that has to do with this column is saved in the same monolithic approach. Then IFC is powerful in representing and documenting element classification, product properties, but it falls short when we are designing, when we have dynamic data. But it's the industry standard and it is supported from many design tools, and we can export and document very good information about the designs that we have. Then on the other hand, how do we interoperate between different tools? It's Speckle, which is different from IFC. We don't compare it. IFC is a data schema and Speckle is a tool that allows you to communicate between 2 softwares. It's not the same, even though they are in the same slide, just to clarify. Speckle is an open source web-based collaborative framework, and it actually offers one neutral schema for specification and creation of basic geometry types and different objects. But its object library mainly depends on the source where this geometry was created. It has around 150 object models. So it has doesn't have a large object models library, but one can create custom objects and work with it. But it has a lot of connectors to different design softwares. And then we have also BHoM, which is the building habitat object model. It is open source, again, collaborative framework. What is different between Speckle and BHoM and let's say IFC is that BHoM slightly covers both. It has also an object library, what IFC has, but at the same time also adapters to connect different softwares. And what is different again from both of them is that it doesn't have one representation of a building element, but it offers multiple discrete disciplinary representation of building elements. And therefore it doesn't have one object for a column, but it has more. And this results with a rich object model library with over 1,200 object models. So what is again crucial and different from other platforms, it has that it is split in 4 categories. It has the object models, it has the engines that operate on data. So it splits the functions from objects. It has adapters to map and translate data between different softwares. And it has interfaces in design softwares where we can use it, where functionality is exposed. You will have a better detailed presentation on BHoM after this talk, but it was to mention because it's somehow, I will talk about BHoM also in my other slides a bit. And now we had tools to data schemas frameworks to interoperate. But then we know that on the other hand, there is this amazing technology, semantic web technologies, which follow a graph data structure. And the standard data model in the semantic web technology is RDF, and is the resource description framework. Again, I won't talk too much about this because tomorrow you will have a big lecture on semantic web and knowledge graphs. But what is important to know is that you can have complex search queries, you can have inference, you can make new claims about data, and it's based on graph data models. So a way to represent knowledge are knowledge graphs. Knowledge graphs represent a collection of interlinked descriptions of entities, objects, events, or concepts. And knowledge graphs put data in context via linking and semantic metadata. And this way it provides a framework for data integration, unification, analytics, sharing. However, all this data that we talk about, it should be somewhere. Therefore, the World Wide Web Consortium designers created the RDF data model, which is a standard data model for describing resources and data interchange within the W3C. So RDF is structured in triples, which consist of subject, predicate, and object. Simple as that. And so this is the way how an RDF statement is constructed. And the term semantic web refers to W3C vision of web of linked data. And web of linked data is built on top of standards such as HTTP, RDF, and URIs. And to exemplify how such technology or a graph data model works, here is an illustration. For example, we have Bob. Bob is friend with Alice, and Alice visited Eiffel Tower. And here, maybe in Eiffel Tower, it's a bigger graph and data structure about Eiffel Tower. And then Eiffel Tower is located in Paris. Paris is a city, and Louvre is located in Paris. And if we want to query some information in the simple graph, for example, we want to query Da Vinci starting from Eiffel Tower, we can query information from cross databases. And that is the beauty of knowledge graphs, because everything just can be reached from different paths. And there are a lot of technologies that use the same approach. For example, Amazon. I buy some items and someone else buys some items, and then I get a recommendation which tells me, hey, one person who bought item B also bought item A, also bought item B. So it just assumes that I can also be interested in that item just because someone else bought the same item that I did. Then we have Google Maps that uses the shortest path or the fastest path. Then we have Netflix. Netflix also uses knowledge graphs. One people who watch movie A also watched movie B. And then we have LinkedIn or Facebook. A lot of friends know Tim. You probably also know Tim. So it's based on the graphs and the connections that we have with other people. So different technologies use the same approach. And these technologies are also present in our architectural engineering and construction industry, because semantic web remains one of the most promising solutions to link data from heterogeneous systems. And building industry for sure has a lot of heterogeneous systems. So here I presented some main ontologies that are used in architectural industry is the building topology ontology. And then we have IFC represented as a knowledge graph in OWL, then brick schema, and there are many more others. So we see that there is one technology in computer science field that is very good in linking heterogeneous systems. And then we have this problem that can be solved with knowledge graphs, that we have this problem that we want to link data with each other. So, but let's go back to the current design tools and how we interoperate. So how do we actually interoperate? If we try to see this in a data part, there are different ways, different distribution of data and different centralized and distribution in different layers. But one can say that currently in architectural practices, we either have distributed interoperability across almost all layers, then we have a centralized one, and then we have federated one. In a distributed approach, we don't have a common database model. We might not have a common data schema. We might not have also the same data exchange format. And then we share files, we share data in whatever way. One example of this is the tool ecology. So you start with Rhino, then Grasshopper, then you import it to Revit, and then you export something to Excel, and then you visualize it. So it depends maybe on the phase, it depends on the discipline. But in such case, there is no authority that has, let's say, the right to say that this is right or this is wrong. And there might be maybe some connection just between these two tools, and this tool is not informed of what is happening. Actually, this doesn't really need to be only file-based. It can also, Speckle also employs a similar mechanism. So then everything can be saved in a centralized way, but still we have a lot of tools that are distributed and then just share information across them. Then we have IFC. How does IFC solve the interoperability problem is that it provides a common data schema. We have a big monolithic data schema, and every discipline fills in this schema with information. Then that is the common truth. Everyone uses the same. And we have many tools that IFC supports, mainly commercial tools. And then we have the shared data schema for everyone. And the exchange format might be the same sometimes. If we use Revit, might be different if we use different tools, but we have the common data schema. But that in a way that contradicts with the nature of multidisciplinarity of architecture and of the building industry, because the way how we represent things actually impacts the way how we want to analyze them. If we want to do some energy simulations, we probably don't need all the information that the schema has. Then we need to filter them, and then we need to show them. So I've seen so many energy simulation tools that run just within Grasshopper. You take the geometry and some weather data. So then actually the way how the building industry is fragmented and split in different disciplines is quite contradicting with the monolithic approach of data schemas. So then on the other hand, we have this federated interoperability, which is like distributed, but we have a shared ontology. So we can have a common database model. So everyone uses the same database. And then we have disciplinary data schemas, but with a shared mapping system, shared ontology. And then we can have totally different exchange format, because regardless what is the format that we have one shared ontology that we know what an element means in that discipline and what does it mean in my discipline. So there are many different tools that have the shared ontology and share the same database model. And in this case, BHoM actually quite aligns with a federated interoperability, because first it allows to have multiple discrete disciplinary representation of building elements. And then it has adapters, like this layer of shared ontology. It has adapters to map concepts between different disciplines or platforms. And what is also actually crucial that I didn't mention here is that we need to be able to customize our information, right? Because if I want to represent, for example, this element differently, I want to edit and extend the data dictionary. And BHoM actually allows a very easy way to extend and edit the data dictionaries. And then it also separates the objects. Where are the objects? It separates objects from functions, which makes it easy to be used from visual programming languages. So this is, for example, one wall can be represented in different disciplines. It can be a physical wall. It can be one analytic facade element panel, but it can be just a planar surface as a geometrical representation. So it all depends on what is the way that we want to analyze this element, and then we define the way how we represent it. But currently, these objects, they live separated from each other. And there are ways how we can estimate one from each other roughly, but there is no relation that knows, for example, that this geometrical wall is the same as this physical wall. But we have the properties, and all of these elements, they have their own object models, which means BHoM, in a way, it is already one ontology, which describes the parts and wholes. But what is missing is the relation between these objects, and it is not represented in semantic web standards. So actually, this problem to link these different objects with each other can be easily solved with semantic web. And also then we can have an overall schema of these elements using semantic web technologies. So that's why, that's why BHoM, in terms of describing whole and parts, it is an ontology. It has a shared schema, but it does not link the objects to each other. Therefore, it doesn't have this layer of shared ontology. And this can be solved with semantic web. So there are some parts, there are key parts to be able to use knowledge graphs, and this federated interoperability in general is that first we need to have disciplinary representation of building elements, to have this shared ontology or ontologies that can be aligned with different modules of ontologies. And then we need to have a database model, which is common, and all of them use the same database model because we want to integrate the data. Then from data, we reach the information, knowledge, and wisdom because we have everything connected with each other. Yeah.
Many of these concepts anyway we will repeat later, so don't worry if you don't catch everything. Yeah, we'll go through these things more in depth later.
Yep. So now, again, what is the goal of how we want to use, let's say, this workshop and the tools that we provide is we need to model data. We need to have a schema of this data. What is the overall schema? We want to define some rules and restrictions, constraints. Then we actually need to have some actual data, objects with attributes, and we need to convert this to the common standard data model that when we can actually really integrate data. And then, so we can query data across different disciplines. So then we can even see, for example, if I have some constraints in one discipline, I can reach it from another discipline. So this is a workflow how one could reach to a whole knowledge graph using some objects, which is building some information models using knowledge graphs. So for this work, until I showed now, we already, as I said, have more than 10 months that we researched on what should be used. And if you are interested, you can see all these papers. They are both in ResearchGate, where we talked about interoperability in architecture, in engineering, construction industry. Then we talk about knowledge graphs and how we decided to use the BHoM framework and why we are using the BHoM framework and why we are showing this in this workshop, because it has a data dictionary. So it has the object library. It is in a way an ontology. It's not in semantic web, but it is an ontology. And on the other way, it has an open and extendable data dictionary because we want to customize data. And sometimes, I don't know who is familiar with IFC, sometimes it's very hard to adapt and to change data dictionary in IFC. But in BHoM, you can directly do it from visual programming languages. And then the other thing is that it already provides this multiple discrete representations. It has many adapters, and the structure of BHoM is quite similar with knowledge graphs. You probably can see it better when Alessio will take over and explain BHoM, how it actually works and what exactly is it. So now we have been working on converting the object-oriented database model of BHoM to the standards of semantic web technologies. So then it means that everyone who actually is using design tools can directly be in the world of knowledge graphs within the design tool. Then there were some steps how we converted, what are the differences between the two models. And we have done this together with Alessio, Al Fischer, Thomas Wortmann, Daniel Hernandez, and Stefan Stab. So it means that right now, the converter that we have worked on, it can be directly used in Grasshopper, and you can have a live graph of data available to work with. And then you can explore it, draw conclusions, but it is at the same time. So I'm working in Grasshopper, and then I have the live graph, and I can do something with it. For example, one thing how ontologies could support collaborative design tools is that you can directly connect concepts. Here you have the concept of a column. Here you have the concept of a bar, which in essence, both of them are the same, are a representation of the same build physical asset, let's say. Then you can say with semantic web standards, hey, this column is the same column as that. And then you can query information, for example, from this material to this bar, even if this doesn't have the material property, just because these two things are the same. Just to show it in a graph, we can have the same graph. You have a column, you have a line, and maybe the start point is the same. So it's quite flexible to manipulate with this data on a graph. Oops, sorry. I forgot to remove my voice. I need to delete it because I had it prepared. Okay. So then I go back. So here we can see how knowledge graphs are accessible through design platforms. And we have, for example, here we modeled with BHoM one timber column, and then here we have the graph of that same timber column. This is visualized using another tool, but the RDF graph that can be generated from this is the resulting. So then we can see this column here is this node here. And then we have the line, and then in the graph, we also have the line. And right now we have it encoded as a turtle TTL format, which you probably will learn about this concept during the BHoM lecture and during the semantic web lecture. But whatever can exist right now in BHoM and can be modeled in BHoM can be converted directly to a knowledge graph. Here with Alessio, we did the full conversion of the structural namespace and all elements that exist in the structural namespace of BHoM to a knowledge graph, and it resulted with this huge graph. And here, for example, we have generated a graph only for some specific elements. For example, we have a small building, then we can design their elements and see the relations between the spaces. But then what is the best part actually comes after it, because you have a graph, then what do you do with the graph? This is the best part that comes. You can actually infer knowledge. You can use all the beauty of knowledge graphs using rules, using reasoners, data validation. For example, if this is a simple example how it could work is that you can have some facts in knowledge graphs. For example, you say that every roof panel is a building element. And then you have one more axiom. You say that every roof panel weighs 15 kilograms. And then you have some rules or some restrictions, let's say, that you have a cyber physical construction site and the robot needs actually to build this building. And the robot has a load capacity, which is 12 kilograms. And then we have this 4 axioms, and then we can use a reasoner to infer new knowledge. And the new knowledge that directly can be inferred is that we say that robot picks and places building elements. And a roof panel is a building element, then we know that robot picks and places roof panels. Then we can use the reasoner again, actually, and we can query some information like, can the robot carry all building elements that we have designed? And then the system will check the robot load capacity and the weight of roof panels, and it can tell us no. And then in future, this can be combined with some recommendation system. Then you add also a message. Then you can even send this message directly to the design tool. And the message, the response can be, no, this cannot be done. Please change either the roof panel properties or change the robot. So then you should change one of these 2 facts. And then you can think about what is more, like, for example, this is a fixed thing that you cannot change. then you directly say, just change the roof panel. So then there is also a lot of work in the recommendation system, how it can be designed. But it is quite powerful to think how we can query data from combined data sources, because let's say that all this information and facts can come from different disciplines. I put here architectural design, structural design, acoustics, and then maybe we have a restriction from fabrication. And it can be combined with some facts from the acoustic design, and then you discover a new fact. And then from this fact, you can discover a new fact and a new fact. And then the graph is added with more and more knowledge. So it means that you can actually draw many conclusions, and you can understand many more implicit knowledge. Right now in databases that we have, there is just the explicit knowledge that you see. But when you combine these things together, the knowledge that you gain out of it, it's huge. Then you can actually really have an intelligent recommendation system that you can do what you want with it. So in knowledge graphs, it's just worth to mention that you can do different things. One of them is you can infer new knowledge. One of them is you can validate data. And there are different technologies to do both of them. To infer new knowledge, you can use rules or facts. And then to validate data, Shackle is the shape constraint, is the language that you can use for validating data. And then just to continue to conclude, last month I participated in a linked data in architecture and construction summer school, and we did a similar concept actually, where we start with a BIM authoring tool. We had an internal hackathon where we had to show some ideas and to develop something that we can use knowledge graphs and link data in architecture. And we did tackled a similar topic. How do we interoperate, and how we communicate constraints, and how we check the quality of data based on some requirements from different disciplines. Then we started with one BIM authoring tool. We converted this information to a knowledge graph. The BIM authoring tool was Articat. Then we exported the IFC file. Then we parsed the IFC file in some link building data ontologies. And we used also some restrictions using semantic web languages. Then we checked if the information that we need is there. Is the graph satisfying the requirements that we had? And we brought this back through a BCF viewer directly as a message to the BIM authoring tool. I will show also this example and some other examples that we can apply in architectural world using knowledge graphs and semantic web technologies as examples, so we can see what we can do with it. But for today, I will conclude with this slide. And if you have any question or anything that you would like to discuss, please unmute yourself. Else, this was from my side for today. Thank you very much.
Thank you for the
Hello,
presentation.
Diellza. For speaking, or should I continue?
I can stop sharing. Am I still sharing? Yeah. Wait. Okay, I stop sharing.
Hello, Diellza. Thanks for the introduction, and it's very knowledge intensive. Actually, I have a couple of questions. The first one is that in the previous kind of this questionnaire, we have the BHoM and also Speckle as the interoperability software or toolkit. Why have you chosen BHoM instead of Speckle as the kind of interoperability tool?
So we chose actually
like
BHoM. Why we didn't choose Speckle?
Yeah, for example, yeah.
I go back to my slide. We can also let Alessio respond, but then
I can add on that. Actually, if you can pull up the slide, I think it's useful.
Okay, share screen.
It's because BHoM has the kind of data engine to do some analysis.
Yeah.
For example.
Well,
it's more about it's more about the federated approach that BHoM takes. So essentially, as far as I know, I have worked with Speckle quite extensively. The thing is, Speckle is more about exchanging data and not really about how data is represented. and which is, an alternative approach from BHoM. It's absolutely valid, but it's mostly for workflows where you care about transferring data, and that's it. Whereas BHoM actually tries to tackle another problem, which is how you represent data and how do you actually agree on representations of things in the world and how they can be, kind of described in a digital format, in a digital way. So essentially BHoM takes a federated approach where every specialist, like if you're a structural engineer or if you are, I don't know, an MEP engineer or an energy specialist, they can all define their own vocabulary of things. So essentially how, for example, how does an architect think about a column? The architect will have a certain way of describing the column. And then if you talk to an engineer, a structural engineer, and you ask him how a column is defined, then he will have a different, he or she will have a different representation or idea of a column. And BHoM allows you to define those two things in very different ways. So you can essentially define the structural column or the architectural column in BHoM with your own kind of schema. And then it defines conversions between those schemas. So you can perform interoperability between those different representations. That's kind of the key of BHoM. Then also BHoM also has certain things that overlap with SPECL. For example, you can transfer data naturally, but that's not the strong point of BHoM. It's mostly defining an agreed representation of data of things in the world. And also building functionality on top of those representations, if that's clear enough. We will go through these things better in detail later when we actually, I have a presentation on BHoM, which will clarify even further what BHoM does. I think SPECL is much more famous because, it's immediately used right now for workflows where, it's solving an urgent problem, which is how you do transfer data between different people, users, etc. And I think it's great. However, there is a much more long-term problem in the industry, which is exactly these. IFC, I believe, hasn't solved all the problems, and BHoM is kind of an alternative answer in the sense that it's providing a schema that's open source as well. So so people can actually contribute to define that schema.
Yeah, actually, that is a quite detailed answer. And how, maybe I can ask you just right now, what you already used SPECL. What was the main purpose? There is a...
Actually, I've used both. I've used BHoM and SPECL both.
Why? What was the purpose, the main idea for you to use SPECL? Like, why did you need SPECL?
Actually, we want to transfer, for example, a Rhino and Grasshopper model to a Rabbit model. And we don't want to use, for example, a Rhino inside a Rabbit, this kind of integrated tool. We want to separate the front end and end in a certain way. And also BHoM and SPECL, actually, I have considered why we use SPECL because probably it's because my knowledge about BHoM is still very limited. I haven't thought of the presentation of the knowledge graph. But SPECL is like it's something on the cloud, and it's basically send and receive information, and also has the 3D web viewer, and that is something very good to show to somebody else.
Exactly.
And from my understanding, actually, SPECL can be also this federated schema, because you can define an object, SPECL object, and extend its attributes.
But that is actually the problem, because you can do it, but you don't have to start from scratch anytime, because we don't want to reinvent the wheel every time. And then starting from scratch, it's what makes it hard. But BHoM already has this library that you can just build on top of that. And SPECL doesn't have it. SPECL doesn't have a lot of objects. Of course, if someone prepares, if you have, let's say, an internal agreement, you create some SPECL objects, then you can convert it to knowledge graphs and work with it. That's also a perfect solution. But it doesn't have this initial objects, semantically rich objects that BHoM has at the moment.
I think. Go ahead. Sorry.
Yeah, I'm just saying that for Speckle, actually, just because there's no predefined schema, so it's very flexible to work with. It's like we can really very define exactly what information we need to transfer. And actually, I've been thinking it just a probably very naive idea. It's possible to transfer BHoM object with Speckle.
Sorry, yeah, there is a Speckle toolkit in BHoM. Yeah.
Okay,
yes, sorry,
nice.
I developed that. The thing is, it's been, I didn't have time lately to update that to Speckle 2.0. So yeah, that's a workflow that used to work. It's not currently working, this full disclosure, but that's definitely something that, it was immediately experimented with. And yeah, it was working at some point. So we could actually convert BHoM objects to, and export them via Speckle and receive them anywhere. And hopefully that's something that, that will be picked up in the future. So if I don't have time, but somebody else wants, that's definitely something we should explore. And there is the basics, it just needs upgrading. But if you look in BHoM, open source organization, you will find a Speckle toolkit that's doing that.
Oh, that's great. I'm really looking forward to it.
Yes.
Thank you, Hao. That's a nice
question.
discussion. That's a nice question, actually.
Yeah.
So that it's great. Actually, it's the key question here, because I know that most people probably have familiarity with Speckle. BHoM is not as famous, and there are reasons for that. As I said, then it's perfectly fine. The thing is, they are solving different problems with different approaches, I think. And but there is no reason why they shouldn't be working together. I think they should. And that's always something I've always tried to push, more integration between the two. It's a bit tricky because, it's tricky like everything, but it's definitely something that has happened in the past and we should continue as making happen.
Yeah. But I have still one question. This is I think, probably a trivial question. It's like the semantic web, this word I just have heard since this workshop. And I've made a very rough Google research. The semantic web is kind of one version of Web 3.0. I don't know whether I have misunderstood something. It's a version of
I didn't get
Web
it.
3. Kind of semantic web is one version or one branch of Web 3.0.
I'm just a bit. It's W3C.
Okay. W3C. Yeah,
I think it's a different. Yeah, but it is. So that is the. Yeah, I think they are slightly different, but both of them are, let's say, web technologies and work on the web. But this is slightly different with a Web 3.0, which is Web 3. And yeah, there are slightly different technologies, but both of them run on the web, and both of them are built on top of HTTP and the web standards. If Daniel actually is right now with us, I don't see him, but Daniel probably could give a better answer.
Yeah.
Let me double check with Daniel.
I think Web 3.0 is more about the blockchain technology.
Yeah.
Which is
it's a kind of
which is that you use, in a way, it's also knowledge graphs, but it's a different form of representation where you're using tokens instead of nodes, but you can still imagine them as the same thing. The technologies are very different, and I think the overall idea, like that is something which I'm interested in looking into, which is that how can you disintegrate a building and take it onto like a blockchain framework, and then take it to different stakeholders. But I think you're very right in comparing semantic web with Web 3.0. The overall idea is same, but the technology is very different for both of them.
Yeah, I understand. Yeah, so Web 3.0 is kind of blockchain, and also the property or the product itself belongs to the creator. etc. provides something different from this semantic web.
Yeah, and I think the common thing in both of them is that it's connected, like the information is connected to each other. Same as in tokens in Web 3.0 and in ontologies, like in, I mean, RDF format. That's the common thing between both of them.
Thank you, Sahin.
Yeah. Okay.
I actually have a question if I can ask right now.
Yes, sure.
So I have like a very general question which I was trying to understand. Like I saw you showed a grasshopper implementation of the same idea, and how can we do that? Somehow for me, I always imagine semantic technologies to be working on an urban scale, where you have information from, let's say, like Wikipedia, and you want to connect some facts with a particular part of a building or maybe material, you know. So somehow I always imagine semantic technologies to be working on that scale, but I never thought that how can you use it on a building scale. So if I'm a designer and if I'm doing a project in Grasshopper, which I think 90% of the time we are working in one particular design element, like the design part of a building, right? So like, what would be my use case of a tool like this? Like, how would I go about representing like a piece of a building, right? Like you were showing there were rebars and then columns.
Yeah.
But me as a designer, how would
I guess if I can try to respond, and then if someone wants to add something, I kind of understand you are working in an urban scale, and I see actually there is a very good group working on this knowledge city graph at the ETH, if I'm not mistaken. They collaborate with Singapore, and they have a lot of projects how they use knowledge graphs in urban scale, because it actually makes sense to know the context and to know the relation between spaces. But when we go back to architectural scale, now we argue on the need for multiple representation of a single building element. I kind of have a feeling, I studied urban design before starting my PhD. And when I started my PhD, I thought, okay, now it's just one building, it's just some building elements. But the complexity of the relationships of these building elements and the way how we can model data is quite high, because you want to represent something that is relevant just for one discipline. And that is what makes it, let's say, interesting, and what you can integrate in the single architectural building. And then you can also include information for fabrication. But if you want to use it in urban scale, you can think what kind of information. Maybe you can combine it with some space syntax, you can combine it with some walkability, some accessibility analysis, and the amount of people that can reach this place, and with some dynamic systems that can explain better the space. So then you can draw some conclusions on it. Maybe if you want to work during this workshop in an urban scale project, tomorrow we will form the group, so we can see people who are also interested in applying it in urban knowledge, and we can have in the breakout sessions, we can discuss and try to find a topic that you could actually use knowledge graphs in an urban scale.
I see. Thank you for that. My question was, it's also more about that. How do you see the application of it? Like, would a designer be only one who is working with the tool and creating the knowledge graphs, or do we see like all the stakeholders working together on a building?
Well, that in my personal opinion, it should be democratized, and everyone should be able to convert their data to a knowledge graph. This is, for example, the converter that Alessio and us work together, that you can just design as a designer, but there is a tool that converts it to a knowledge graph, and then this should be appended to a bigger knowledge graph, and then you have rules and you have some restrictions that you can communicate with other people, and you don't need to do all the work, but everyone should be able to convert their information, to add their information to a knowledge graph.
I see. Thank you for that. And then another question I have was,
thank you.
Another question I have was that, correct me if I'm wrong, but ontologies have been there like for I think 6-7 years now. Like people have been researching a lot, and I know like if like Revit is like one of the common softwares which have been like used for BIM and representing data. And I don't see any like bigger companies like Autodesk who are just going
using ontologies.
Yeah, like
then I will invite you to some events and you will see Zyplin in Stuttgart, they are using ontologies. Niras in Denmark, they are using ontologies. Now, Bureau Happold, as you see, we are also developing ontologies. Alessa, you're muted.
Yeah, sorry, you